Hi everyone. In this video I'm going to work out some of the exercises on page number 1 of the review for test number 5, which is your homework 6.3. In question number 1, we have to write the equation of the line that passes through the points -4, 4 and 2, -8. This topic was covered before test number 4. And so we have to write the equation. And the equation would be written in slope-intercept form. Therefore, to write this equation, we need two things. We need the slope and we need the y-intercept. But as we can see here on the equation, none of this is given to us. We're only given 2 points, and we don't have the slope and we don't have the y-intercept. But we can find the slope by using these 2 points, using the slope formula, so that it would be the first thing that we do. Find the slope by subtracting the y values, y2 minus y1, that would be -8 minus 4, and then x2 minus x1, that would be 2 minus -4. On the numerator, we have -12. -8 minus 4 is -12. And on the denominator, we have 6. Negative times another negative becomes positive, so it's 2 plus 4, which is 6. And we could simplify this. We could actually divide -12 by 6, and that would be -2. So now we have the slope, which is -2. And now we can use the slope in one of the points. Let's use this, let's say for the second part, we can use the slope in one of the points to find the y-intercept. We're going to use the equation in slope-intercept form. Y is equal to mx plus b. Substitute the y from the point. The y is -8. Substitute m, which is what we just got over here, that's -2. And we substitute x from the point, which is 2. And we need to find b. So in this case, we have -8 is equal to -4, because -2 times 2 is 4 plus b. Now to solve for b, we need to add 4 on both sides. Doing the operations, we have b is equal to -8 plus 4 is -4. So now we have our y-intercept, which is -4, and now we can write our equation in a slope-intercept form by substituting the slope and the y-intercept. The equation would be y is equal to -2x minus 4. The slope has been substituted with -2, and the y-intercept is -4. So this is our equation. In number 2, we have to find the x-intercept and the y-intercept, both of them. And for that, you're going to do that procedure that has 2 parts. You will substitute the y with 0 in order to find the x-intercept, and in order to find the y-intercept, we substitute with x equal to 0 and find what those intercepts are. I'm not going to do this one, but this has 2 parts. I usually do it in this way. So to find the x-intercept, substitute y with 0. That's 3x plus 4, and y is substituted with 0, equal to negative 24. And you simplify to see what's the x-intercept. To find the y-intercept, you substitute x with 0. So the equation will look as 3 times 0, because the x is substituted with 0, plus 4y is equal to negative 24. And then you solve the equation for y in order to find the y-intercept. I will leave for you to finish this exercise. In number 3, it says the table below shows a relation that is a function. Which order pair, when included in the table, will make the relation not a function? Explain your answer. So this exercise is dealing with functions, but you need to remember what a function is. And a function is a relation where every value of x corresponds to a different or to only one value of y. So let me repeat one more time. A function is a relation where each value of x corresponds to only one value of y. So in this case, this is a function because each of these values of x corresponds to only one value of y. The 2 only corresponds to 7, 5 only corresponds to negative 3, 3 only corresponds to 5, and negative 4 only corresponds to negative 2. So the question is, if we were to add one more point here on the table, which of the points that we have here will make this, which is a function right now, not a function anymore? And that would be 0.51, because you already have a value of x5 here. So this would not be a function anymore because the value of x5 corresponds to different values of y. That would be the explanation that you are being required here. It says explain your answer. So in this case, that would be 5.1. That's the point that makes this not a function. Why? Because x equal to 5 corresponds to two different values of y. Which are negative 3 and 1. So remember that this is something that is not good. If you see repetition, that means this is not a function because the value of x corresponds to different values of y. And of course, talking about functions, you also need to be able to determine if a graph is a function or if a set of numbers is a function. So review what we did on functions after test number 4. In question number 4, it says the graph of a system of linear equations is shown below. What is the solution for the system? We learned that the solution for a system is the point of intersection. In this case, these two lines intersect at this point. So we're just being asked what are the coordinates of this point. That would be the solution. So just write the coordinates and find it here on the list. I will leave that for you to finish. In exercise number 5, it says determine if the system has one solution, no solutions, or infinitely many solutions. Explain. Notice that nowhere it says graph, and we don't have the graph paper for us provided in order to graph this. So the point is not to graph, but just to be able to determine whether this has one solution, no solutions, or infinitely many solutions without graphing. So the only thing that we're going to do is compare the two equations and see what are the characteristics that this system has to see which one of the three cases is this system. So the first equation is already solved for y. We see here the slope and the y-intercept. Slope 2, y-intercept -4. The second equation is not solved for y, so we need to solve for y this one. 3y plus 12 is equal to 6x. To solve for y, first we need to subtract 12. And this would give us 3y is equal to 6x minus 12, because these two terms here, they cannot be combined. They are not like terms, so we just have that. And finally, we simply need to divide by 3 each part of the equation, and that will leave us y is equal to 6 is divisible by 3, so 6 divided by 3, that is 2x, and -12 divided by 3, that is -4. Now we can see the slope, which is 2, the y-intercept, which is -4, and we compare with the first one, we can see that both of them have the same slope, which is 2. Both of them have the y-intercept, which is -4. So that means both equations are on the same line. That means the two lines intersect in all the points. Therefore, it has infinitely many solutions. So this would be our answer. Infinitely many solutions, or simply infinite solutions. Why? Because both equations are on the same line. And that will be the end of this problem number 5. And I think it's important that we remember what are the other two cases when we have one solution. For example, is when we have one point of intersection. I'll be writing here on the side. So when we have one solution, that means we have one point of intersection, and that is given by one characteristic only, which is different slopes. The other case, when we have no solutions, is when we have parallel lines And that is given by two characteristics, same slope and different y-intercepts. Different y-intercepts. So those are the other two cases. One solution. No solution. In number 6, it says which equation represents a line parallel to the line of 3y minus 2x is equal to 6. Justify your answer. So which of these four is parallel to this one? Parallel, very important. So that has to do with what we just reviewed here in question number 5. Parallel lines, we know they have the same slope and different y-intercepts. That's the case when we have no solution. So that is what we're looking for here. Which one of these four is parallel to this one? So I need to take this equation, which is 3y minus 2x is equal to 6, and solve for y so that I can compare the slopes and the y-intercepts with the other ones that I have here. So in order to solve for y, I need to add 2x on both sides. That will give me 3y is equal to 2x minus 6. And then we divide it by 3. And that will give us y is equal to 2 is not divisible by 3, so I'm not going to divide. I'm just going to keep that as 2 over 3x, and negative 6 divided by 3 is negative 2. So we have a slope of 2 over 3 and a y-intercept of negative 2. Now we want parallel lines. It should have the same slope that we have here and a different y-intercept than this one. So we look into our equations, same slope, 2 over 3. We have negative 3 over 2, 3 over 2, negative 2 over 3, 2 over 3. That's the same slope. And you can also see here that the y-intercept is different than negative 2 here. So this is our line that will be parallel to this one. Why? Because they have the same slope and different y-intercepts. That will be our justification, our explanation. They have same slope and different y-intercepts. And in question number 7, it says solve by graphing. You need to graph each of these equations here on the coordinate plane that is provided for you. The first one is ready to graph. You have your slope and your y-intercept. Slope of 1 over 2, which means go up 1 unit and 2 to the right, and the y-intercept is negative 3. So starting on the y-axis at negative 3, you will go with this slope, 1 up and 2 to the right to get more points, and then you graph the line. In order to graph the second one, you need to solve for y. So take down the equation here. solve for y. That will need subtracting for x on both sides. That would leave us with 2y is equal to negative 4x plus 14. And then we need to divide by 2. So y is equal to negative 4 is divisible by 2. Negative 4 divided by 2 is negative 2x. And 14 divided by 2 is positive 7. So now you have solve for y, the second equation, identify the slope and the y-intercept, and graph both of them here, identify the solution. This should have a solution because you can see here the slope is 1/2 and this has a slope of negative 2. They have different slopes, therefore this should have one solution. Graph them, identify the solution. And that's it for page number 1.